So welcome to this segment again as I try to continue with quick revisions paper 1. I'm going to show you some other sample questions that you can do under estimations relating to absolute error, relative error, and also percentage error. But this was an exam questions. There was that point there, so I just want to show you still how you can go about it. It was saying that A, solve the equation. So how do you solve 2x raised to the power 2 is equal to 8? I think this was direct. You can divide 2 so that you remain with just x squared is equal to 2 into 8, because they are 4 times. Then the next thing that you're going to do, you need to get rid of that square. So the only way, you introduce the square root. What you do this side, you also on the left hand side, you do it on the other side, but this side the square root will either be positive or negative. So I'll remain with x is equal to plus or minus the square root of 4 is a 2. So therefore you conclude that your x can either be positive 2 or it can be negative 2, and this is what they wanted you to do there. Well, I thought I could actually give you another question that came in another exam. Hopefully you are able to see that. That's why I'd actually put it in those type of square brackets. So it says that 2x to the power 3 is equal to 16. Again, you simply need to remain with the x, so I'll divide 2. I'll also do it the other side, so it will be x to the power 3 is equal to 2 into 16 goes there 8 times. So how do I get rid of that? Because there's a 3 here, you introduce a cube root, so you show the 3 there. What you do this side, you also do it the other side, but here remember it will be plus or minus, so this and that will cancel. X will be equal to plus or minus. Cube root simply means what is that number? That when you multiply it 3 times, it will give you 8. So it is simply 2. So x again can either be 2 or negative 2. So this is the way you would have actually gone about it. So it was very simple. Yeah, so we go back. So we go back again to to errors, so that you are able to see how to go about it. So question number 1b there, question number 1b there is what we are now going to focus on. So 1b there says that the mass M of a bag of meal is 25 kg. So this is number 1b, is simply 25 kg. Complete the statement. So they want you to complete the statement, and that statement says dash is less or equal to M, which is the mass, which should be less than that one. So how do you complete such a statement when they have given you that? Well, you need to find the upper limit and the lower limit. Since they have given us the mass of the bag is 25 kg, so we need to find the upper limit and also the lower limit, and that will help us to fill up what we have. So that dash is less or equal to M, and M is less than dash. So here we are going to put up what we call as being the upper limit, and there we are going to, we are going to put up in this case the lower limit, and the other side we are going to have the upper limit. So that's what we are actually going to do. So the lower limit minus the upper limit, and the other side the upper limit. So our job is simply to do that. So how do I find the upper and the lower limit? Remember, you need to find the least unit of measurement. For a whole number, we said it's 1, and therefore this will help us now to find the absolute error. How do you get? You get the least unit of measurement 1. You divide by 2. 2 into 1, it cancels. Write a 0 and a point. Add a 0. 2 into 10. That will be 5. So that is what we mean. So now this mass, for you to get the upper limit, you get 25. Remember that mass now, let me just write it here. The mass can now be written as 25 plus or minus 0.5, and this is in kg. That's the way we can write it there. So you need to get the upper limit by saying 25. You get the positive part plus in this case 0.5, and you need also to get the lower limit by simply saying 25 minus 0.5. So that's the way you are going to do it. So when you add 25 plus 0.5, remember you can say 0.5 then 0.5. I hope you're picking up that. I'm trying to show you this because I've seen a lot of students make mistakes. 0 and 5, that will give you 5.52. So this will be 25.5. That is going to be your upper limit. Then the next thing that you are going to do is simply for you to get what we are calling as being the lower limit. So it will be 25.0 minus 0.5. So you can get 110 minus 5 will give you 5. I'll remain with 4 minus 0. I'm going to have a 4 point, and that is going to give me a 2 there. So this is what you are going to have there. So you can see I've actually gotten 24.5 as simply being the lower limit that you're going to have. So now we can actually replace in the statement that we have there. So we can actually get to replace in the statement, but how is that going to be in this case? So how is that going to be? Remember what I told you, once you find we are completing that, so you need to replace the lower bound or the lower limit and the upper bound. So how is that going to be? Let me use a different marker. So I'll get the lower bound, which is actually that one. So it will be 24.5, and this is in kg, should be less or equal to m, and m should be less than the upper bound or the upper limit is simply 25.5 kg. We have left it like that because this, according to this sign, it means this is not included, so it is less than 25.4, because we want to maintain the actual value to still be 25. We don't want to change anything. So this is the way you could have actually gone about calculating that. Hopefully that actually helps you. Let's move on to the second question there. Let's move on to the second question there and see how you can actually get to calculate that. So let's see how you can actually get to calculate that. So for number 2, it says let me just bring it down so that you are able to see there. Number 2 says that Bwadia estimated the length of a string as 15 centimeters. If the true length was 14.6, find the absolute error. So remember what I told you. So the absolute error can also be gotten by the modulus of the recorded measurement or the recorded value minus the true value. That's what we said. So what is the recorded value? According to the question, they said what he estimated the string to be 15. So that's what he recorded. Minus the true value or the true length, they told us it was 14.6. So we just need to subtract, in this case 15, which we can say 15.0 minus 14.6 there. So we can get 1 there. 10 minus 6 is a 4 point. I've remained 4 minus 4 is a 0. 1 minus 1 is a 0. Therefore, it will be 0.4, and that will still give you 0.4. So this is the absolute error that they wanted you to get in the first place. So that's the way you needed to go about it. Then how do we get the relative what? The relative error from that question. So how can we get the relative error from that question? Well, that becomes very simple. B, remember what we said, relative error is equal to the absolute error over the true value. So the absolute error was a 0.5 divided by the true value, which is simply 14.6. Now, of course, you need to leave it as a fraction in its lowest terms. So this is to 1 decimal place, it is to 1 decimal place. So I'll multiply by 10. I'll also do the same there. So when I multiply it, I'll just have a whole number 5. Then here I'll have also 146. Let me just do it from here. So the relative error will be, can we reduce it further? That's the question that we need to ask ourselves. Is it possible that we'll be able to reduce this, further? Can we reduce it? Is there a number that can actually go into 5 and 146 without leaving a remainder? The answer is basically no. That number that you're going to have is simply going to give us a decimal point. I think that's the lowest value that you can have. Otherwise you end up, so meaning you don't even need to go further. This is the lowest that you can do it here. So thank you so much. So this is what you are able to do. Well, let's look at another question there. Let's look at another question that I have there. Now call it as being question number 3. All these are examination questions. Why? Because I want you to practice and see a variety that you are going to be getting. It says the mass of a loaf of bread is so the mass of a loaf of bread is simply 702.1 grams, correct to 1 decimal place. Find the lower limit. So before you can find the lower limit, you need to know first of all the least unit of measurement for a decimal number. Since it is to 1 decimal place, it will be 0.1, and therefore remember what we said, the absolute error, you get the least unit 0.1 divided by 2. By now you are familiar with what we did there. When you divide there, it will be 0.05. Remember what I said, you can ignore the point there and say 1 divided by 2, which can that go there? No, 0 and the point, add a 0. 2 into 10 is a 5, but because these are the 1, you move it backward by 1 point, and that's why we're having that. So now when you have it that way, this mass can simply be written at 702.1 plus or minus 0.05, which is the absolute value. That's what we did. So now the first question says find the lower limit. So the lower limit or the lower bound will be equal to 702.1. the lower bound you subtract minus 0.05. So let's try to do it from here. So 702.1 minus 0.05, that's what we mean here. You can deliberately add a 0 there. So 0, you can get 1 there. 10 minus 5, that will give you 5. Here will remain 0 minus 0 is a 0.207. So the lower bound will be 702.05, and that is going to be in grams. So this is the lower bound that you needed to get. Then the other question says that we find the relative error. So B, how do we get the relative error? Remember we said it's the absolute error over the true measurement or the true value. So the absolute error, what we got there, 0.05 divided by the true measurement 702.1, and that's what we are having. Let's try to see if we can actually try to reduce that. This one has to 2 decimal places, then this one is to 1. So you notice this one is to 2 decimal places, this is to 1, so you multiply by the highest, so that's by 100. I'll also do it here, so meaning the relative error will be equal to on top I'll have 5 over here, I'll push it twice in front, so I have 7021 and a 0. So this is what I'm going to have there. Then we now need to reduce it. 5 can go there. 5 there will give me 5 into 5 is 1 over. Can 5 go into 7? The answer is yes. That's 1 time. So I'll write 1 remainder 2, and that will now become a 20. So that is now going to become a 20. So can 5 go into 20? Yes, it is actually 4. Then I'll go to this 2. Can 5 go into 2? The answer is no. So you write a 0 here and get the next number. Into 21, yes. And that is again, simply 4, remainder 1. That one will go, I'll get the 0. Into 10 is simply 2. So meaning this is the value that you needed to find there. Thank you so much for watching. Please take time to go through so that you understand what we are doing. So that's the value 1 over 14,042. So that's the last value that we have. Thank you so much for watching. If you love what we do, please you can subscribe or share the channel with others. Enjoy your lessons.